Okay, in this video we're going to be graphing absolute value functions and transforming them as well. So in my linear transformation videos, we've seen that if you have the parent function of f of x and you add 2 to it, then it shifted up 2. Okay? If you subtracted 5 from it, it shifted down 5. Okay, that's 4. There's 5. Okay, so let's see what happens when you do the same thing with your absolute value functions. Okay, so real quick, let's figure out what this is. And if you're not quite sure how to calculate an absolute value function, if there are 2 videos that go over that. If you'll go back and watch those and review that, I'm not going to take the time to show you that here. Okay, so let's try to graph. This is the parent function. F of x is equal to x. Okay, and so let's plug in some values. So when x is 0, f of x is the absolute value of 0, which is just 0. So we'd have a point here, okay, at the origin. When x is 1, f of x, the absolute value of x, is 1. Remember, it's just taking the distance even when we're going into a positive direction. Okay? So we got 0, 0, 1, 1. And when x is negative 1, then the absolute value of negative 1 is 1. Right? You have negative direction but positive distance. So let's plot those points, and they're right there. Okay, and if I kept going, if I kept assigning x values, I should end up getting this function. Kind of looks like a V, right? Absolute value. I think about it, value starts with a V. The function looks like a V, so that might help you out with that. Okay, so that's that. Let's try and graph the next function, absolute value of x plus 2. Okay, so when x is 0, f of x is 0 plus 2, which is just 2. Okay, when x is 1, f of x is absolute value of 1 is 1 plus 2, which makes 3. When it's negative 1, absolute value of negative 1 is 1. So then 1 plus 2 is also 3. And so we should get these points at 0, 2, 1, 3, and negative 1, 3, which is over here. And you should get a function that looks like this. Again, it's a V. And notice when we added 2, the graph of the parent function shifted up 2 units. Okay, let's try the next one. F of x is equal to absolute value of x minus 5. So again, assigning values. When x is 0, then we're going to have 0 minus 5, which is just negative 5. When x is 1, absolute value of 1 is 1, minus 5 is negative 4. Negative 1, absolute value of negative 1 is 1 minus 5, again, is negative 4. And so we should end up getting this. So we have at 0, negative 5, 1, 2, 3, 4, negative 5, 1, negative 4, and negative 1, negative 4. And we should get a function that looks somewhat like this. And notice, all you're doing is you're taking the parent function and shifting it down 5 units. Which means that the transformation ended up being the same as the linear transformation. So when you take your absolute value function, f of x equals absolute value of x, and you add some constant k, the parent function should translate vertically. It's going to undergo a vertical translation. The same thing as the linear function.